This is part 2 for our review. We're given this power series g of x equal to this. We're asked to find the interval of convergence for this. So this isn't a straightforward geometric or anything like that. So probably the ratio test would be our best bet here. So the ratio test says take the limit as n goes to infinity of the absolute value of the next term divided by the previous term. Now, since we're doing absolute value, we don't need to worry about an alternator. It's not going to matter one way or the other. So we can just go ahead and go x minus 10 to the n plus 1 over 8 to the n minus 1 plus 1, which is 8 to the n, and then x minus 10 to the nth over 8 to the n minus 1, okay? And we want this to be less than 1. So when you do ratio tests, you know, in the previous section, you saw what this did and then interpreted, but we want to force this to converge, and so we want it to be less than 1. And so if you flip this and simplify, what you end up with is the limit as n goes to infinity of x minus 10 over 8. Now, you can let n go to wherever it wants. There are no n's left over anymore. They don't really play a part. So this kind of just evaporates, and we look at this. If I do the absolute value piece of this, multiply by 8, and then add 10, we end up with this. X is between 2 and 18, right? So that's going to be our initial idea. Anything between 2 and 18 is going to work. But we want to make sure we understand what's happening at the endpoints as well. So what we want to do first is let's put 2 in for x and see what happens. So if we do that, what we end up with is negative 1 to the n plus 1 times 2 minus 10, so negative 8 to the n over 8 to the n minus 1. Now there's a lot going on there, right? And so what I think might be helpful is to go ahead and pull negative 8 out of this. So let's go negative 8, okay, times, and then we'll have negative 1 and n plus 1. If we were to take 2 negative 1s out, they would cancel each other out, right? So n plus 1 and n minus 1 are no different. So I'm going to write that as an n minus 1. We've taken a negative 8 out, so now this is going to have 1 less negative 8. And the reason I did all of this is now the exponents are all the same. So if I were to combine and divide, negative 1 times negative 8 is 8, divided by 8 is 1. All of this here equals 1. And so we end up with just the summation of negative 8. That means you'd be adding negative 8 plus negative 8 plus negative 8 forever and ever and ever and ever and ever. That diverges. Can't be 2. So let's see if we can equal 18. If I put 18 in, I get negative 1 to the n plus 1. I get 18 minus 10, which is 8 to the n over 8 to the n minus 1. Now this one's a little bit easier to see. If I pull an 8 out, I'll have 8 to the n minus 1. Those will cancel right away. And so I'll have negative 1 to the n plus 1 times 8. Now, what does this mean? This means you're going to be adding 8 plus negative 8 plus 8 plus negative 8 plus 8 plus negative 8. So this isn't going to keep getting bigger and bigger and bigger, but it isn't going to converge to a value either. So this also diverges because it keeps oscillating back and forth and back and forth and back and forth. So that's our interval of convergence. They want to see the ratio test and then these endpoint checks to see what's happening at each one. Now, B says, can you write the first 4 terms of G prime? And I think the easiest way to do that is to go back and figure out what were the first 4 terms of G. So put 0 in for n, put 1 in, put 2 in, put 3 in, start to get a pattern for G of x, and then just take the derivative of those terms. So if I do G of x here, if we put 0 in, we're going to get negative 1 to the first, so that's going to be negative 1. This to the 0 would be 1. And then this to the 8 to the negative 1 would actually flip it up, and we would end up with a negative 8. So the first term here is negative 8. Then I'm going to put 1 in. If I put 1 in, I get negative 1 to the second, so that's positive 1. X minus 10 to the first over 8 to the 0. That's just going to give us x minus 10. Okay. Put in the next one. I'm going to get a negative x minus 10 to the second over 8. Put in the next one, becomes positive x minus 10 to the third over 64. Put in the next one, I get x minus 10 to the fourth over the next one of these, which would be 512. You could write it as 8 squared, 8 to the third, doesn't matter. These are your first few terms, all right, of g of x. So what would g prime be? All right, g prime would be the derivative of negative 8, which is 0, the derivative of this, which is 1, then the derivative of this, the 2 would come down. We'd have a negative 2/8, so that's a negative 1/4 times x minus 10 to the first. Okay. Then plus, and then the 3 would come down. We'd have 3/64 times x minus 10 to the second. And then this time the 4 would come down, so it'd be minus 4 over 512, which you could leave. If you wanted to make it 1, I think it's 1/28 x minus 10 to the third power. There would be simplified your first 4 terms. You don't have to simplify them. But the best thing to do is figure out what the terms of g of x are, and then just take the derivative of each of those terms, rather than try to take the derivative of this and then work it out. I think that's harder. Same thing here. What are the first 4 terms of the integral? We'll go back to g of x and integrate it. So the integral of g of x would be the integral of negative 8, which is negative 8x, plus the integral of this, which would be x minus 10 squared over 2, minus x minus 10 to the third over 3 times 8, which would be 24, and then plus x minus 10 to the fourth over 4 times 64, which is 256. There's your first 4 terms then of that. That's the easiest way to do it. All right, and then this one here gives us a h of x, which is this kind of complicated thing, and it says using a power series for e to the x, can we write the first 4 terms for just this? This is how the AP sometimes will do it, rather than make you do it all at once. Just can you do it in pieces? So e to the x we know is 1 plus x squared over 2 plus x to the third over 3 plus so on and so forth. And the general term for that is x to the n over n factorial. Okay, so that's what we know e to the x is. So if I want e to the 2x to the fourth, then g of x will be 1 plus 2x to the fourth, put that in there, plus 2x to the fourth squared over 2 factorial, plus 2x to the fourth to the third over 3 factorial. And they asked for the first 4 terms, so 1, 2, 3, there's your first 4 terms. Now we got to get a general term. So you can be just as general as saying 2x to the fourth to the n over n factorial. Okay, I mean, you can do that. Or if you want to work it all the way out, it's 2 to the n, x to the 4n over n factorial. That's just giving that n power to both of those. Either one of those is fine. Okay. Now, using the power series from part A, write the first 4 terms of the general term for h of x. So how is this different? H of x is all of that we just figured out, okay, minus 1, and then take 2 x's away. So the minus 1 is going to take this away, right? So h of x will not have this 1 to start with. It'll just go like that. And then what we're going to do is we're going to divide by x squared. So we're going to take 2 x's away from each of these. So it's going to be 2x squared, 2 x's away from there. This will be 2 squared, so it'll be 4x. This was x to the 8th, but we're dividing by x squared, so it'll be x to the 6th over 2 factorial. Plus, now 2 to the third, that'll be 8x to the 10th. And again, that 10th comes from, this would be x to the 12th, but we're dividing by x squared. Right. And then if I kind of follow the pattern here, I would have 2 to the 4th, so I'd have 16x to the, you can see we're adding 4 here as we go, over 4 factorial. So those are your first 4 terms. The general term then for this, you know, if I make this n equal 1, n equal 2, n equal 3, n equal 4, you can see that I've got 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. So this is 2 to the n. And then it's x to the 4n minus 2. I'm adding 4 each time, so 4 times n, and then I take 2 away, which makes sense because I had the 4n here and we divided by x squared, so we took 2 x's away, so that's why that makes sense. Over n factorial. There's our general term for that. So now it says, using the power series from part B, can you determine if h of x is concave up or concave down? So to do that, we have to think about the second derivative. So the first derivative for this would be 4x plus 24x to the 5th over 6, or 2 factorial, plus a bunch of other stuff. The second derivative for this would be 4 plus 120x to the 4th over 2 factorial plus a bunch of stuff. Well, here's the deal. All this other stuff has x's with it, right? So if you do the second derivative of 0, all of these are going to zero out except for the 4. And since that's greater than 0, h of x is concave up.